This is an interactive 3D visualization of Mars. The base map was created by the USGS based on imagery from the Mars Reconnaissance Orbiter HiRISE camera. The white line represents the traverse path of the Spirit Mars rover through the Columbia Hills in Gusev Crater. There are spheres placed at every position where Spirit stopped to take high-resolution stereo images. The spheres look like small bright dots when viewed from far away. When the viewer moves the camera close enough to any of these locations, a terrain mesh from the rover's imagery is overlaid onto the map. Here we can see the terrain meshes constructed from where Spirit originally arrived on Mars and her 300-meter approach to Bonneville Crater. The framework behind this visualization is Artor 3D, a powerful scene graph-based 3D engine for Java. The smooth flyover of the terrain of Mars uses Artor 3D's GeoClip Map terrain system. Artor 3D can run standalone or be embedded into an Eclipse RCP application. This flexibility made for a straightforward integration into NASA's Ensemble software application framework, which is built on Eclipse RCP. Where the base map gives us a view of the terrain in pixels that are 1 meter in size, the rover images provide detail that is 2 orders of magnitude greater. Using this visualization, the viewer can fly over any location where the rover took imagery, double-click on the position, and fly down to get a look at the terrain from the rover's point of view and at the highest available resolution. This view has many different applications, such as reviewing historical mission data, identifying new targets of opportunity for the science instruments to analyze, and planning safe traverses to new locations. One of the most challenging areas to visualize is home plate, where Spirit has spent several years capturing an extensive collection of imagery. Here there are hundreds of image meshes that are all in the same vicinity. This dataset demands a great deal of attention to effective memory management and caching in order to create a smooth interactive viewing experience. Level of detail management is used to show or hide terrain meshes based on the distance of the viewer from the surface. JPEG 2000 compression for terrain and image data allows the application to load new data quickly. We hope to further mature and extend this visualization to provide activity planning support for the Mars Science Laboratory mission, which is set to begin in 2011. We hope you have enjoyed this presentation of our Mars mission visualization.